All right, then. Hello, everyone. Welcome to the next episode of the YugabyteDB Friday Tech Talk series. And my name is Kannan Muthukkaruppan. I'm one of the co-founders at Yugabyte. It's my pleasure to welcome you all today. Happy Friday. And I have with me my colleague, Shawn Sherwood, and would love for him to introduce himself and also then get into the topic for today's talk.
Okay, thanks, Kannan. Hi, my name is Shawn Sherwood. I'm a solution architect with Yugabyte. And some of my responsibilities here at Yugabyte are to work directly with our customers when it comes to adopting Yugabyte and all the work that it's involved in, either doing data migration or application modernization, and a lot of the enablement that goes along with that process of moving from, say, a traditional relational database to a distributed database. And this specific topic, the YSQL connection metadata caching, was something that was implemented as part of work that I had done with a customer, specifically a multi-region environment setup where they're very latency sensitive, and this specific feature I think will what did and has helped with that one specifically. So I think with that, I'll just jump in to discuss what this feature really is about. So the background again is this there's an observed behavior that typically surfaces in a multi-region environment. And so I've got modeled here a situation where I have a 3-region cluster, US West, US Central, and US East. But in this configuration, I'll have an application, say an application pool that will connect specifically to the West nodes. But my data and my catalog, Postgres catalog leader, all of the leaders are going to be in Central. And there is a measurable latency between these two regions. So in this model, say 32 milliseconds. So what happens is when an application or even through a YSQL SH session makes a connection to one of those hosts, one of those T servers, the very first query that you run on that. So let's say I'm going to issue this pretty simple select star from YugabyteDevice where ID equals 1. On the server side, the Postgres query planner kicks in, and it needs quite a bit of information from several post PG, specifically like PG underscore catalog tables. And when I've measured this, the request that ends up having to go across the network, it's not just one. In this specific query, I was able to measure 52 specific cross-region RPCs, in addition to that original one just for the data for the YB device. And if you were to kind of just do the rough math on that, that could actually lead up to like 1.6, 1.7 milliseconds of extra latency. And as I said, it's the first query of each connection that this is surfaced where you have this. The second query, the third query, they don't have this problem. They don't see this additional extra hops. So where you would observe this and where it becomes more problematic is when you do have these higher cross-region latencies. So I have an environment already stood up here, one without this cache turn on. It's a 218 environment. I don't have any flags enabled, so this is just kind of vanilla behavior. As I said, I have my nodes, my 3 nodes. My preferred leader is in the central region, but I'm going to connect to this west node. And here I have an environment where I've connected onto the node. I'm just going to do a simple YSQL SH session. I have timing automatically turned on here, so we'll be able to see the timing of this first query. So if I run the query, run it by hand here, you can see that there's an observable amount of latency. In fact, it's even a little higher than I predicted. This about almost 2.5 seconds. As I said, there's the follow-on queries are actually, they don't pay that penalty. They are, the 32, 33 milliseconds of latency between my region. But the again, it's that first query on that first connection. If I do a subsequent connection, let's just say I do this again, you can see the time shaved off a little bit. That is just a little bit of the overhead of that very first connection to a T server that's just been freshly started. But it is pretty close to that time that I predicted that it would take for this query to run. And I've actually already looked at.
And maybe one comment I would make. Yeah, so I think you're pointing out two things. One is the first query in any connection is getting involved in the statement planning and statement preparation. And in the statement preparation is where we need to query all these catalog tables. And if the catalog tables are needed in a different region, then there's a lot of like warm up time. But in the subsequent executes, we're pretty much down to just seeing the 30 millisecond latency just to get the data itself, right?
Just to get the data.
Yeah, and even for that, suppose the application can live with follower read semantics, then that could even drop to 1 millisecond, like if you, right?
Correct.
But independent of whether for the data we are doing follower read semantics or late consistent read, yeah, the statement preparation time is this big bottleneck in multi-region deployments, right? Yeah.
Yes. And I was able to capture from the Postgres logs the actual requests that were being made during this query execution, and actually map them back to the individual Postgres catalog tables, so like PG class, PG index, and how many times those were being called. And this gave me a little bit more information to go on to kind of understand the scope and scale of the problem.
And Shawn, there's one more question on, maybe if you could stay on the YSQL shell. So suppose let's issue that, go into a new YSQL shell and issue that first query again. Yeah. So now let's do a few things. Can we change the shape of the statement a little bit, like say select created underscore by just one, like, but it's on the same table name. Is this also considered a first query, or because YB device is already cached, you get some? So that is one question. So looks like on the same table, even though this query had a slightly different shape, it didn't have that penalty.
It doesn't have the exact same penalty. Actually, let's start it.
No, what the question is like, if the second query in this connection is to the same table but a slightly different shape, right, then it doesn't have the penalty. Like if you just remove the correct, right? Now,
yes.
Now the follow-up question is, what if this was a different table name? Like their question is like, is it literally the first query or the first query to a specific table?
It's predominantly the first query, but it's not just the first query, because if you issue statements with some additional shapes to them, just like you're talking about, there would potentially be some additional RPCs to some additional tables.
Yeah, like maybe your select statement had a built-in like a SQL function, and it might have to go back to the catalog to say where, what is this function, what is the return type, and so on, right? But
yes,
what if do you have another table in your schema that we could try, like select star from a different table, perhaps with limit 1 or something?
Let's see. I have a device, I believe, model table.
Maybe just say limit 1 or something like that. Yeah, so when the shape changes or when the table name changes, there's more catalog lookups that happen.
Correct. And so you can see when I run that same one again, that it's now down again to that latency for the single RPC. So when I think about this, it's not, It's true. You're right. It's not really just the first query, but it's the shape of the queries that you really have to think about in the scope of the problem. And I'll actually talk a little to that with the feature of the connection caching enabled. So as I said in 2.16, we added this capability. So there's a G flag. It's not on by default. So YSQL enable read request caching. So if you turn it on to true, what it effectively does is it preloads a handful of those PG tables and loads them into a local node cache. So when your first connection is made to the T server, the metadata lookup that happens can take advantage of that being local as opposed to having to make the remote calls. So the end result being is it will really drive down the additional latency that you saw on that first query, and even the subsequent queries that if they're different shaped, they'd have different where clauses and things like that would also benefit from this. There's another side benefit of this as well, because of it's like in environments where you have a large number of connections and say they ramp up really quickly. You can see a lot of pressure on that the reads from that catalog table because so many additional RPCs would be coming in on those first queries. And this, because it can keep a lot of those requests local, reduces the effect of a connection storm.
And one more question coming in, Shawn, is this optimization or is this issue specific to read queries, or it applies to write queries or write latency?
It pretty much implies to any query that the planner it has to do some planning on.
Correct. It doesn't matter if it's a select or an insert. The statement preparation or the compile time is where this optimization really helps reduce.
Yes.
Go ahead.
Yes. So in this, with this activated, I just put these little boxes to represent this local node cache. And what effectively then is happening is as the very first connection is established, these tables are getting preloaded into each of these T servers local cache, and then become available for the first connection or any connection then that's established to that node. So as connections come in and queries are executed on them, any of the information that the query planner needs, if it's in those local tables, doesn't have to make an RPC. And for this query, this fairly straightforward, fairly simple query, I calculated that one and ran that one, and I could see an additional, instead of 52 additional ones, I had it drop down now to just 8 additional RPCs. So shaving off what was measurably in seconds now to about 250 milliseconds. And I can show you that I have another environment, the second one with this cache enabled. Real quick, I'll just show the G flag. I have this turned on to true. This additional flags, I just wanted to show it that it was false, that it's not enabled. I'll talk about that next. But in this session, so this, again, I'm on a West node, YSQL SH. And I'm going to invoke that query, the same query again. And you can see this time a significant improvement. And again, I think if we were saying, let's try a different shape of that query, or actually, let's try what we were doing before, YugabyteDB model. I'll do a limit 1 on that. And you can see there is still some additional overhead because it's a different shape. But if I do the subsequent query, we're talking then back it down to that small number.
That's correct. It's just to get to the other region. Yeah.
Yeah. And again, follow-up queries. You'll even see it come down just a little bit, but it'll, again, the first query still does pay some additional penalty. And when you look at it again underneath the hood of what are the RPCs that are being invoked, you can see obviously it still has to have a call to to the main table where the data is, but there's several of these additional calls that are to other tables that weren't part of that flags preload list.
Yeah.
And actually several of them, there's 4 of them here that are actual indexes of PG metadata tables.
That's right. But at least even on any new connection, the first query is no longer taking anywhere close to that 1 second plus number that we saw.
Correct.
But
Correct.
what you're saying is that initially we're kind of loading not the entire catalog. That could be prohibitive. So there is some trade-off here of how much you want to cache in every T server. And I think maybe that's what you're going to go down the path of, like, are there additional tweaking or tuning that can be done here?
Yes. Yeah. So it is a subset of the tables, and the reason you see the additional latency is just that it's going for information that isn't already preloaded.
Yeah.
There is another flag that was included in 216, and it's just to say preload additional tables, and effectively it just adds a few more tables to that superset of tables that get preloaded. It's meant to help balance the memory overhead of loading too many tables. And in this case, it just added like an additional 4 tables to that set. But for like this specific query, when I run through this model, it really only took one RPC off the table for me, because specifically those extra RPCs that you saw in the previous log really didn't benefit a whole lot. So that said, in 218, with this version that I have, there was an additional flag included, and this one is a lot nicer, because specifically this says let the user define which one of those Postgres tables, the PG metadata tables, to load. Basically, it's just a comma separated list of tables, and then it gives you that flexibility to define which ones. And when I did this research, and I came up with the list of tables that I wanted to add, it gave me that extra benefit. If you already have those other flags enabled, it's really just going to create a subset of, or sorry, a superset of those tables. It won't like double load them. But in my case, I really just wanted these 2 additional tables here, the PG AMOP and PG operator. And in this flow, when I have my first query run specifically, same query, same kind of setup with this enabled, I got it down to two total RPCs. It took off everything but one additional RPC, and that one is to an indexed this specific PG operator. So even though I loaded PG operator, this index is kind of like a cache miss. And my understanding of this one specifically is kind of underneath the hood, in the Postgres query planner code, there are apparently some calls that happen that can kind of circumvent this caching layer. I've got a GitHub open on this, and I'm already working with engineering on it, because hopefully I think we could get this to even a better place. But I wanted to kind of show this one off. I have my last environment where I have that flag enabled. So this is 218 with the read request caching turned on, and the additional tables list where I've specifically called that out. This is the very first connection to that environment, and I'm going to run the query by hand. And now I'm down to effectively 67 millisecond call for that very first call.
And then if you do it again, it'll be back to just the call for the data row. Yeah.
Yep. Yeah. So the math kind of works out. You can see that if my cross-region latency is smaller than this, then the total effect is smaller. But it's really just a multiplier of your latency, your cross-region latency, by how many extra RPCs that are going to have to be made.
Wonderful.
So there are additional things that you have to think about, and the obvious one here is memory. So the extra memory that's needed to preload and pre-cache this information, it isn't free. So you will have to think about this. And the individual T servers, I don't think it's necessarily the big concern, but ultimately it gets down to the connections, the individual Postgres connections. When you make a connection to the database, effectively every connection is a spawned off Postgres process. And when I was doing the actual measurements on this, as I was adding these flags and adding tables, I was using this SMM tool, and specifically looking at the USS, the unique set site, or unique set size, to measure that Postgres process and the delta between when I had the flag turned off, when I turned it on, and when I added additional tables. And I could see this measurable difference between, with it turned off, a process was about 10 megs of unique space, but with these tables preloaded into each one of these connections, it bumped it up to about 45 megs. So in your specific environments, you will have to look at, if you enable this flag, how much memory is it going to consume, and how many connections do you expect to have? At max, the default is like 300 total connections. So you'll have to potentially do a little bit of memory tuning in your environment. And I've linked here a blog from a colleague of mine that has some good documentation about what are the potential settings, like the default memory limit to RAM ratio, and how to free up more memory, specifically for like the Postgres processes.
This is a good, overall, this is the good point. Like, ideally, as a system, we want to introduce very few knobs, right? Like ideally, this should be all automatic. There's a little bit of a phase in the journey where some knobs have been added. But if you think about it, fundamentally, this is one trade-off. Like this kind of caching, the amount of data we cache depends on the number of objects in the catalog, the number of tables, the number of, it's just like everything, like every view you have, every stored procedure you have, multiple schemas, objects, indexes, they all increase the size of the catalog. And so today, it kind of solves for what some may consider a problem, whereas some others may be okay to live with. Like, how important is the first query latency inside a connection? If that's not a huge deal for you, if you're mostly keeping long-running connections, you don't have to touch any of this, right? If it is a little bit of an important deal, even the first query latency, and you have a reasonable number of objects in your system, not too high, then this is a easy default to kind of turn on to get that additional benefit of very predictable latencies when you're warming up connections. But otherwise, there's still some work that we'll be continuing to do to more make this page be incrementally refreshed rather than loading the entire cache, which is what kind of presents this memory challenge. So stay tuned for more automatic things coming down the pipe. But go ahead. Sorry, Shawn, I interrupted you. Maybe some.
No, all I was going to say is kind of to that point is, if you're going to look at this, you'll probably want to do some of your own testing, where you do SMM and like on a connection that's been that's had your workload run on it, because there are additional things that are going to be loaded, like all of the based on how many tables you have, how many stored procedures you have, etc. So it can vary by environment.
And one more question, Shawn, is when enabling this feature, is there a performance degradation that can happen when establishing the connection?
I have not noticed it specifically with like the Java application connections. In fact, I feel like they've been faster. But that it does, like when you hit the YSQL it does feel like there's just a little bit of extra delay when it's turned on.
My intuition would be that if you're using it for the right use cases, meaning when you don't have, see, like we pointed out, that if you have tons of objects in your catalog, this caching has a memory consideration. It's going to preload a lot of stuff. So in some sense, when the T server starts up and is building this cache, the hit is somewhat in that place to build the cache. But then for each of the Postgres connections, the cache should strictly be a benefit, like each of the client connections that are coming in, because now you're more likely to pull things off for your local T server's cache as opposed to going to IB master. So yes, there is some, I would say it's more a memory trade-off, but I wouldn't expect it to have a performance hit. In fact, your connection, because your connection, as generally the next steps are you start running your queries. So essentially your application warm-up is going to see a huge benefit.
Yeah, and like if you do have a connection pool, almost all connection pool implementations won't hand off a connection until it's actually been established and logged in and validated. So if there was any additional overhead, it would probably just surface and maybe the application would take another second or two to start up.
That's right.
In doing that, the research for like, okay, which PG metadata tables are going to be important for me if I want to put them into a custom list, there's a couple steps to enable this. You can enable this YB log docdb request. This effectively will turn on all RPC requests that are coming out of that node in the Postgres log. And what I will do is just tail that log, run my query in a YSQL session, and then capture that part of the log, put it in a text file, and then run this command, this grep. The individual lines are pretty verbose, so this helps kind of extract out really the essential information, and it'll sum it up, and so you'll get the kind of that nice view of how many calls to each particular table by table ID. You do have to do a little bit of hand look up for those table IDs. That gives you the UUID. You'll have to go into the UI and kind of look up the table list and then see each one, and then you'll see which specific Postgres tables that those apply to. But at the end of the day, again, you'll be able to determine which ones matter to you for which queries. And if you get a decent sample of your own queries, you should be able to come up with a decent list. As I said, this is going to be turned on by default in 220, but with some caveats. And one is that the read request caching is going to be enabled by default, but the specific underlying tables being preloaded won't be. If you already were doing that, my understanding is that this upgrade won't revert that behavior, but if you are enabling it for the first time, you'll get you won't get the additional that additional memory overhead. And the kind of the go forward is really focusing on this custom list where you'll be able to then specify exactly which tables you want to be preloaded. That'll give you the best benefit and ratio kind of what you're willing to tolerate for that first query latency if you're in this kind of situation versus the total memory usage for it. And
Great.
I think with that, that's the end of my talk.
Thank you so much, Shawn. I think that's we also just did it exactly sharp on time. Like, oh, there's one more question coming up. How does the node determine that the cache is invalid and thus needs refreshing? Great question. There is, I mean, there are catalog version-based checks internally in the system that confirm whether the cache is still valid to use or not.
Yeah, correct. So it should be accurately refreshed as necessary.
Great. Thank you all for joining for another episode of YugabyteDB Friday Tech Talks for engineers by engineers. And thank you so much, Shawn, for being on this series to talk about an area that you have actively worked on and helped customers with some of their multi-region deployment tuning. Yeah, thank you so much.
Thank you for having me. Happy Friday.
Yeah, see you all.